This is my demo for the Artificial Intelligence Assignment-2. This is the code for the assignment, and you would find two game folders, which is the Connect4 and the Tic-Tac-Toe one. And you can run the file by simply going into the folder and going into the main file and clicking on run. And I've done this for the Tic-Tac-Toe. And in this you can set two players, which is player 1 and player 2. I've set it to the default player, which is the smart player, and the second player is the Minimax one, and I initialize it in the tic-tac-toe class, the player 1 and player 2, and just call the play function in the tic-tac-toe class. And over here in the output it would display the whole tic-tac-toe board and display whose turn is it. So right now it's showing default's turn, then it shows Minimax, then default again, and in the end it displays the result of who has won the game. It would show Minimax if Minimax is won, or if no one has won, then it would be a tie. You can also change the players over here, specifying it as player 1, default as player 2, and run it. This would take a bit of time because Minimax takes a little bit of time to traverse to the tree, and it shows Minimax is 1. Similarly, for Connect4, you can specify the rows and the columns for the board. So right now it's specified as 4 and 4, and I've also set a default depth of 5, but this can be removed also. So I'm going to run the code. So this code runs really fast because it's depth limited. If you remove depth limiting, it would be really slow. So similar to that of the tic-tac-toe board, it shows whose turn is it, and then it displays the board, and in the end it results in a tie. So now I'll be displaying how you can train a Q agent and how you can load it. I've included documentation for both Connect4 and Tic-Tac-Toe on how to load and save your Q agent. So I've just displayed it for 5 iterations because training it for longer iterations would take a bit of time, and it would also give better results. So I've just for displaying, I've just trained a demo QLearning agent. So it shows over here how many iterations and how much time it took. So just for 5 it didn't take really long. So I have also stored it over here in a pickle file, which is a binary representation of the file. And I have two policies which I've already saved, policy QLearning 1 and 2, and I can load any one of them. So I've loaded the policy QLearning 1 and I'm playing it against the default player. So the QLearning agent takes the center of the board as the position, and it plays the same game, and it results in a tie. The same can be done for Connect4. So now I'll be displaying the QLearning player for the Connect4 game. So I've set the player 1 to QLearning with an epsilon of 0, means a total greedy approach, and I've loaded the policy equivalent to that and selected the random player as player 2. I'm going to run it. You can see that the QLearning player has won the game. I'll be displaying the Connect4 board for 6x7. So the rows and the columns can simply be changed over here by specifying the number of columns or rows you want. And I've initialized the QLearning player with a greedy approach and loaded the policy equivalent to the 6x7 board and playing it against a random player. So you can simply run the file, and in some cases the random wins, and in some cases the QLearning agent also wins. So yeah.